Shared authority-based privacy-preserving authentication protocol in cloud computing. Let's move on to the abstract of our paper. Cloud computing is emerging as a prevalent data interactive paradigm to realize the user's data remotely stored in an online cloud server. During the data accessing, different users may be in a collaborative relationship. In existing security solution, focus only on the authentication to realize that a user private data cannot be unauthorized access, but neglect the subtitle privacy issue during a user challenging the cloud server to request other users for a data sharing. The challenged access request itself may reveal the user privacy no matter whether or not it can obtain the data access permission. We propose a shared authority-based privacy-preserving authentication protocol to address the above privacy issue for a cloud storage. For example, shared access authority is achieved by anonymous access request matching mechanism with security and privacy consideration. For example, authentication, data privacy, forward security, etc. The attribute-based access control is adapted to realize that the user can only access its own data fields. Proxy re-encryption is applied by the cloud server to provide a data sharing among the multiple users. The universal compatibility model is established to prove that the SAPA theoretically has the design correctness. It indicates that the proposed protocol realizing the privacy-preserving data access authority sharing is attractive for a multi-user collaborative cloud applications. This is the data flow diagram of our project. There are 4 people plays a vital role in our project. They are data owners, cloud service providers or a cloud servers. It acts as a cloud storage and trusted third party, and remote users or end users. Data owners can upload the file to the cloud service provider or a cloud server. While uploading the file, the data owner generated with a secret key. For each data owner provided with a secret key by a cloud service provider. The cloud service provider has a bidirectional sharing with the trusted third party, and the CSP can only permit or deny access if the user is unauthorized person or authorized person. If the person is unauthorized, the user is blocked by the CSP. They cannot access any file by from the CSPs. If the person is authorized person, the remote user requested the secret key to the cloud storage, and the requested secret key is entered to the process, and the remote user can decrypt the file and download it. The trusted third party plays a vital role in this. Why? Because it monitors the user, what they upload and download, if they are authorized or not. Like this, the data owner send a metadata to the TTP, that is trusted third party. Between a data owner and a remote users, there is a data sharing. By this, the data integrity and forward security improved well on this encryption. This is our overall DFT. Let's move on to our demo of our project. This is the home page. In this, the 3 peoples are data owner, cloud service provider and remote user. In this, the data owner can upload the file to the cloud storage. The cloud server stores that file that are shared by the data owner. The remote user or a end user can access the file through the cloud service provider. Let's move to the data owner. In this is the data owner page. In this, we have to enter the owner name. Here I enter the owner name as ETPL 1. Select the file type. Select the file type as Java. Browse the file. This is the file content. While clicking the upload button, the file is uploaded to the cloud service provider. It stores the file that is shared by the data owner. The file is uploaded successfully. To view the file, these are the list of files that are stored in the cloud. The cloud server maintains these files through the secret key. The owner name is recently we have stored as etpl1. The file name is dist.java. The secret key is 203592. Through this only the end user can access the file. And the second process is to send a metadata from the data owner to trusted third party. The metadata sent successfully. While clicking the encrypt button, the file is encrypted successfully. It is under the base condition of the attributes access based encryption. This is the file content that is encrypted form. To decrypt the file for monitors the user by the trusted third party. To view the TTP files, this is the list of files that are stored by and monitors by the trusted third party. The etpl1 dist.java, the same as the secret key 203592. And let's move to the end user or a remote user who are going to access the cloud files from the cloud storage. In this we have to enter a username and select the file type and file name. We have one separate condition, that is as we have only rights to access the file stored in the cloud storage. Here the username is system access. The file type is Java. I am going to access the file name as dist.java. Then the end user can request the secret key to the cloud service provider. For the further process, while the secret key is received successfully 203592, after that, while clicking the download button, through this key we can decrypt the file requested by us and download the file. The file downloaded successfully. This is the file we are requested. While clicking the save button, it is saved into the end user's database. They can access further. This is attacker page, that is nothing but an unauthorized remote user who wants to access the file. Before that, we have to view the cloud files for access. These are the files they can attack that are stored in the cloud storage. Enter the name. Here I entered as host hacker. The file name is dist.java. Here I enter a secret key without requesting to the cloud service provider. Attack the file. The authentication is in progress. It leads to the user privacy. Then authentication done. It proves as unauthorized user and it is blocked by the cloud service provider. After that, to view the attacked files, the attacked files are the attacker name host hacker, the file name is dist.java, through the IP address of this, and under the time of this. After that, then finally we have to evaluate the performance evaluation. It under the parameters of data integrity, data confidentiality, data anonymity, authentication evaluation. While compared to existing, the proposed is achieve a better performance for forward security and user privacy. It leads to the data confidentiality and integrity and data anonymity. Thank you.